Welcome to E-Pathashala Architecture lecture series for MArch students. Now this series is a continuation of GRIHA, Green Rating for Integrated Habitat Assessment. In the previous module, we saw how site planning, site selection is an important criteria for making a building or a design green. In this series, we are going to see about the next criteria, which is health and well-being during construction. The objective is to protect the health of construction workers and prevent pollution. So, GRIHA is not just about the occupants or about the end process. If a building has to be sustainable and green, the construction during the building also has to follow certain criteria or norms. So, the criteria says provide at least, which is the minimum, at least the minimum level of sanitation and safety facilities for construction workers. Ensure the health and safety of workers during construction with basic effective provisions for the basic facilities such as sanitation, drinking water, safety equipment and machinery, which means it is up to the client or the contractor to provide a safe habitation for the workers if it is necessary, which means do not put the workers' life into any kind of a risk. They must also provide basic facilities like sanitation, which could be in the form of mobile toilets, clean drinking water and safety equipments like helmets and things like that must be provided to the workers. There is also another way in which the safety of the workers can be enhanced through psychological means to ensure that all the workers have some kind of a insurance that must be organized by the contractor. Ensure cleanliness of workplace with regard to the disposal of waste and effluent. Provide clean drinking water and latrines and urinals as per applicable standards, which means even on the site, apart from the safety of construction workers, we must ensure that the waste or the effluents that come from the latrines or the toilets or the urinals that we provide must be safely discarded. Criterion 9 is reduce air pollution during construction. At the time of construction, some kind of demolition might happen. Even if there is no demolition, the use of fine grained cements could generate a lot of pollution around the site. So, the dust generated by various construction site activities can contribute significantly to air pollution. Dust and outdoor air pollutants can cause respiratory problems. Good construction practices involve major mitigation measures for prevention or minimization of air pollution from construction activities. This criteria aims to reduce air pollution due to on-site construction. We must ensure proper screening, covering stockpiles, covering bricks and loads of dusty materials, wheel washing facility and water spraying to ensure that we reduce air pollution during construction. Here for example is a building which needs to be demolished. You can see that the demolishing of the building starts from the rear end of the street, which means people on this side, on the facade, do not even know of the demolition activity. Demolition is going to cause a lot of air pollution in the form of fine dust. As this progresses, demolition progresses, the facade of the building slowly will be demolished. When they demolish, screening is mandatory or necessary. Here is an example in the square of Milan Duomo. You can see that some kind of a building activity is happening behind the screen. It is therefore, they have put up a screen here in front which duplicates or replicates the continuation of the facade. This becomes important because it is not only air pollution that is important, but visual is also a criteria. You can see the continuity of the facade here and therefore, the demolition activity does not look like an eyesore. Here is an example in Venice where a construction activity happens. Now, we all know Venice is made up of a lot of pedestrian bridges. When this building had to be renovated, the bridge had to be pulled down, but the people working here have ensured they put a temporary bridge structure here to ensure that the regular visual line of this facade does not get disrupted. So, pollution is not necessarily dust and air alone, but also visual. So, in a green building we need to ensure that pollution of both forms must be avoided. Next is building planning and construction stage. Now, the objective of this is to maximize resource. The resources we have is water, energy and materials. To maximize resource conservation and enhance efficiency of the system and operations. First, we will look at water. What are the ways of minimizing and conserving water? Criterion 10 in this talks about reduce landscape water requirement. So, what are the ways in which we can reduce water requirement? The first important criteria is we can reduce the use of exotic species, which means if we use native species of flora and fauna, we can reduce landscape water requirement because the plants, native plants are acclimatized to the specific climate and therefore do not demand anything in excess. Reduce the landscape water requirement so as to minimize the load on the municipal water supply and depletion of groundwater resources. It may also be brought to your notice that some of the cities, in some of the cities, it is mandatory that we can never use water for lawn purpose from the municipal supply. Every building must generate its own water if they have to water the lawns, but these are not rules which are generic in nature, but they are very specific to certain cities. Nevertheless, it gives us a clue about how we must conserve water. Landscape using native species and reduce lawn areas while enhancing the irrigation efficiency, reduction in water requirement for landscaping purposes are the ways in which we can reduce landscape water requirement. We can also use grey water to harvest our lawn. How can this be done? Grey water is nothing but water that is got from the kitchen and the wash basins. We can use this water for watering our lawns. Of course, there is a rule or a norm that this water can never be used as a sprinkler, but we can use it only subterranean or as drip. Here is another example of grey water reuse. We can see water from various areas of the house is collected like the washing machine or the shower or the kitchen. These are called as grey water sources. So, grey water sources is collected, it can be filtered, sometimes it need not be filtered, and then it can be used for watering our plants. You can see this is how it looks when we water our plants using grey water. This red color container has been used to store the grey water after filtering, and it is used discreetly to water the plants. We can also have a rainwater harvesting system to water our lawn. So, here is the terrace through which the water is collected and kept in large cans, and from here the rainwater which is stored is used. You can see here in this example, this is the house in which there are large containers in which rainwater is collected and it is used for watering the plants. Reduce building water use. This is yet another very important aspect. If we are able to reduce our water use, building water use, we will also reduce the amount of wastewater that is generated. So, it serves twofold. One is we are reducing the usage of a very important resource called water, as well as we are reducing the generation of a waste called liquid, water as a liquid. Reduce water consumption in the building by using, there are two ways of doing it. One is fixtures. We can use efficient fixtures which produce very less water compared to a regular tap, which means there will be more of air than water. but then the entire purpose is also solved. We do get such efficient fixtures. The second method is use of waterless urinal, which I will explain in a short time. Here is an example of how we use water efficient fixtures. You can see that the flow is sufficient for use, but it comprises more of air and water comes as a spray. We can also use sensors here, so that we do not forget to close the tap, and it can also avoid water wastage due to leakages. So, the sensor senses a human hand and then water gets released. Again, this is another example of a fixture which has less water and more of air, but it does solve the purpose. Now, we come to the concept of waterless urinals. Waterless urinals are capable of saving a lot of water. The concept is a blue color sealant liquid is poured into the urinals. The density of this blue liquid is much less than that of urine. Therefore, this sealant liquid always floats on top of the urine and the urinal does not require constant flushing. After a period of a particular time, this blue liquid is replaced with another fresh blue liquid. So, the urinals do not give off a bad smell, and yet we are able to conserve a lot of water. The urinals also have what is called as a eco trap to ensure that the blue sealant liquid always floats over the urine and foul smell is never emitted. Efficient water use during construction. With today's technology, we already have a lot of materials which consume less water, but it is also important an architect is aware in using these materials combined with appropriate construction technology to ensure that we use less water even during the time of construction. At one time, we needed cement which had to be mandatorily cured with a lot of stagnant water for at least 21 days. But today it is not necessary. With new technology in the market, our cement need not be cured for 22 days at a stretch with stagnant water. This saves a lot of potable water. Under this, we will see minimize the use of potable water during construction by using say materials such as pre-mixed concrete for preventing loss during mixing, or use recycled treated water and control the waste of curing water, which means even when we have to cure a particular area, we can ensure that we do not waste too much of water by its flowage. We can have detention ponds which collect 100% of storm water runoff from the site. Here is an example of a building where the drainage of water is such that it all drains to particular ponds, causing a lot of detention ponds. Over a period of time, all the ponds will join together and we will have one large pond. So, this collects the runoff from the neighboring sites and roadways. If we do not collect this water, it eventually goes and gets mixed with the ocean or the seas, which is of no use to anybody. So, if we want to recharge our aquifer, we need to create detention ponds like this. So, the ponds and surrounding wetlands provide sediment, pollution and flood control, apart from being a huge source of recharging our groundwater aquifers. Next, we will see energy end use. The criteria is to optimize building design to reduce the conventional energy demand. So, first is we need to reduce the amount of energy that is demanded by the building. How can this be done? This can be done by applying solar passive measures. Now, solar passive measures are of two types. One is simple solar passive means, another is advanced passive solar means. Simple solar techniques, simple passive techniques comprise of any system which is based on the natural flow of energy such as conduction, convection, radiation, which means an architect, if he plans his buildings properly in such a way, you are able to trap heat through natural means in cold countries, and if you are able to make the building cool in warm countries without the use of any addition measure, then it is a simple passive techniques. For example, being climate responsive, using appropriate orientation of the building, using appropriate fenestration or openings, position of openings, location of openings, type of glass, type of shading devices. These are the methods by which we can reduce the demand of conventional energy through simple passive design. We can also use advanced passive design like earth air tunnels or a passive downdraft evaporative cooling, which is a separate issue by itself. It is a separate module for you to learn by itself. Here we will see how we can have climate responsive buildings, adopt an adequate comfort range, use less air conditioned areas, give appropriate daylighting, natural daylighting, avoid over design of lighting and air condition in order to reduce conventional energy demand. Next criterion is optimize the energy performance of the building within specified comfort limits, which is optimize use of energy systems in buildings that maintain a specified indoor climate conducive to the functional requirements of the building. Ensure that energy consumption in a building under a specified category is 10% to 40% less than the benchmark figure, which can be arrived through simulation exercise of a base case example. So, here we are basically trying to say that we need to look at the indoor comfort conditions and ensure that the designer provides indoor comfort conditions, preferably without the use of any active means. Also, how do we ensure a particular building is consuming less energy? We can consider the benchmark case of how much energy is consumed for a typical building. If an architect is able to design a building which consumes up to 40% less energy, then we can claim it to be a very good energy efficient building. There are very many other materials which are low embodied energy and which we can use. I am giving an example of fly ash because in RCC, when there is a reinforced cement concrete structure, the infill can be made with blocks of fly ash. It can even be used in load bearing structures, in mortars and binders. Here I am giving some examples of low embodied energy materials. This is lime sand brick, concrete hollow brick. When we use concrete hollow brick, you can see that the blocks have a lot of hollow. When it has hollow, it means the amount of concrete utilized inside is less. These materials, this kind of lime sand bricks and hollow concrete blocks can be made of custom sizes to our requirement, and therefore, the erection time is also less, the erection is also much simpler and easier. Here is an example of cement waste slag brick. In case you think using these alternate materials is going to make the building not look very good, here is an example of a building which is made with foam fly ash concrete panel. When we use these kinds of things, when we use fly ash, in foam fly ash, what happens is whatever was supposed to be an industrial waste, we did not have any other purpose, which was actually a pollutant, because fly ash is a very fine dust which goes and settles on anything and everything. If we are able to give it an alternative purpose in the building industry, and that purpose is combining it with concrete and making foam fly ash concrete panel, we are not only utilizing a waste, but we are also bringing down the embodied energy of the building itself. Criterion 16 is reduce volume, weight and time of construction by adopting an efficient technology. So, we can reduce the time and therefore, also manpower can be saved by using certain systems like precast system, ready mix concrete system, etc. So, replace a part of the energy intensive materials with less energy intensive materials and or utilize regionally available materials which use low energy or energy efficient technology. So, if in a particular place there is availability of a low embodied energy material, for example, a lot of good quality clay or soil is available, then that place we can use compressed stabilized mud blocks. So, mud is a very soil or mud is a very low embodied energy material compared to a burnt brick. So, in this manner if we are able to replace, for example, bamboo is a very low embodied energy material. If we can use bamboo in our building, in fact, if we can replace bamboo with a high energy material, automatically the embodied energy of that building is going to come down. Also here we can further see that we need to look at systems of erection. Precast systems are more energy efficient than in situ systems. Using of ready mix concrete is much more energy efficient than using in situ concrete. All this is even more applicable in case of large campuses or large construction where the quantum of these materials is very high or very large. Here I am showing you an example of how mud blocks are made. This is an example of a residence for Prithvi and Purushottaman by architect Chitra Vishwanathan. You can see that the site had a lot of good quality clay, and then this clay was used on site and made into compressed brick. The compressed brick is made with the help of this small equipment. In this, using this equipment, a lot of mud blocks can be made, and using the blocks this house has been done. So, you can see how low embodied energy this building would have been. The soil is got from the site itself or probably adjacent to the site, which means there is nothing much to extract, unlike what would have been caused when you extract something like steel or concrete. So, there is no extraction, it is very minimum. Transportation is very less because the clay here used is locally available, and Manufacture is almost nothing because it is done manually by people. As we had already discussed, anything done manually is normally not considered as a resource in the sense because it provides for their jobs. So, anything that provides them jobs is not considered as a resource wastage. So, you can see people here are manufacturing it on site, the blocks, and without firing, which means there is no need for a kiln also. So, this building must be a very, very low embodied energy compared to a building which is done with burnt clay. A building done with burnt clay has much less embodied energy than a building which is made up of steel and concrete. Here we further see how this machine is used to compress the mud and make blocks out of it. These blocks are, see, this block is dried, sun dried, first sun dried for some time and then dried under shade before it is finally used in this building. Some other examples are concrete hooking panel. So, these panels which are very, very thin, made up of concrete, very, very thin, are fixed in this manner through mortise and grovel joint. They just have grooves which just need to be fixed, and this is the outcome. Instead of having an infill of concrete or brick, they are using very thin concrete panels. Using low energy material in the interiors. So, using low energy material is not limited to the envelope, but is very, very important how we use materials indoors. A minimum of 70% of the total quantity of all interior finishes and products should be low energy finishes or materials or products which minimize wood as a natural resource or utilize industrial waste by using products in any category as listed. Normally, people had been telling for a long time that wood is a natural resource and hence has low embodied energy. In one sense it is correct, but if we look at sustainability of wood as a material, we need to pull down trees, and as I had already told, pulling tree is in a way destroying a smaller ecosystem. So, in my opinion, wood cannot be considered as a very green material. Therefore, in certain cities, in principle, wood cannot be used as a building material, and there are other alternatives which have come. If we cannot use wood, there are other alternatives which can also be used. The various interior finishes used in the subsystem of a building or interiors are internal partitions, interior wood finishes, paneling, false ceiling, inbuilt furnitures, cabinetry, flooring, doors, windows and frames. So, with this what we have seen is how we can use water and energy efficiently in a building. We can use water efficiently by in two ways. The consumption of water must be minimized. It can be minimized by using native species. It can be, when we use native species, consumption of water for landscaping is reduced. Within the building, we can reduce our water usage by using water efficient fixtures as well as waterless urinals. When it comes to energy, there are two types of energy. One is end use energy, another is embodied energy. Embodied energy can be used, it can be reduced by using locally available building materials and then casting everything on site. Whereas end use energy can be used by having energy efficient fixtures within the building. So, with this we complete the second module. Thank you.